So welcome to this talk on evolving Java for the serverless era with Micronaut. For those of you who don't know me, my name is Graeme Rocher. I'm the creator of a couple of relatively well-known frameworks in the Java world, Grails and Micronaut, more recently Micronaut. I work at a fantastic company based out of St. Louis, Missouri in the USA called Object Computing. Who sponsored the development of both Grails and Micronaut. I was privileged to receive in 2018 the inaugural Groundbreaker Award from Oracle for the work I did on Grails. I'm a Java champion, and I've been working professionally on open source since 2007, so nearly 13 years now working professionally on open source. On the agenda today, we're going to look at the challenges, facing Java in general. When we look at serverless in particular, but also microservices and in general, how that impacts the Java platform. We'll look at Micronaut's approach to solving those problems, and I'll do loads of demos. If you look at, from a framework developer's perspective, and I've been building Java frameworks for 12 years now. Every single framework developer out there who builds a framework has to deal with the same, more or less, set of problems which exist in Java, which is a pretty limited annotation API. We support annotations in Java, then annotations have been in Java for a long time. But the way you kind of are able to search for classes that are annotated with something or analyze whether an annotation is annotated with another annotation, also known as meta-annotations, is pretty limited. It also requires you to reflectively access code, often to figure out how annotations apply. You have to reflect into private fields, for example, to figure out annotations on fields. Things like type erasure as well are really problematic for framework developers because you have in your code base you have this beautifully formatted list of string angle bracket generic types, and then when you get to the runtime part, you're like, that's no longer there anymore, and how do I figure out what is this a list of string or is this not? And all that burden of resolution is placed on the framework. And we have interfaces like parameterized type and so forth. That's a real challenge. Reflection as well. There's been so many different solutions concocted to deal with the speed of reflection historically, and it's improved over time. But the bytecode enhancements, runtime bytecode enhancement solutions like cglib and so forth have tried to optimize this. Make it faster. And another major problem for framework developers and for Java frameworks in general, in terms of achieving low memory consumption, fast startup, is the proliferation of reflective data caches. So what is a reflective data cache? So if you think about your typical modern Java stack, where you've got Java, you got Hibernate, you got Spring. Maybe you got Jackson to serialize JSON, etc. Each individual tool builds up its own cache of reflective data for a particular class. So you end up with duplicate caches. You have one, that Jackson builds for marshalling and unmarshalling an object to JSON. You have another reflective data cache that maybe, if you're using Groovy, for example, it builds a reflective data cache for that class. Then you have another one that Spring builds for DI for that class. Then you have another one that Hibernate builds for to read and write to the database. So you have all these data caches that end up occupying more and more memory. And the other thing is, class path scanning is pretty slow. It's being able to scan the class path, and that comes back to our limited annotation API. We need to scan the class path, and dynamic class loading as well. If you have a large class path with a lot of jars and in a large framework, can lead to performance issues in terms of dynamically loading classes. If you look at traditional applications that have been built in Java over the last 10 years, we have this correlation between the number of lines of code in your code base and startup time and memory consumption. And a lot of this, this is very, very typical. I see this all the time in Java applications built today. And as your number of lines of code go up, your startup and memory consumption increases along with it. And what this has led to is, if we look at the frameworks that, were built over the last 10 years for Java, they typically have characteristics that include higher memory consumption and startup time. They have a lot of opinions and auto configurations and so forth. In one corner, which would be my top right corner, and in the other corner, you've got the more kind of do-it-yourself toolkits, I call them, such as Vertex and Spark and so forth, where you programmatically put everything together, but you lose the productivity benefits. And people have had to be choosing one of the others. And when we started to look at designing Micronaut 2 years ago, we thought, why does it have to be this way? We want to be able to build a framework that does not have the high memory profile of a typical productive environment like Spring or Grails, but features the fast startup time and so forth of the do-it-yourself toolkits. When we started this investigation, we realized pretty quickly that frameworks that are based on reflection and annotations become quite fat quite quickly when you throw large amounts of code to them. People love the productivity benefits that an annotation-based programming model has brought to the Java platform, and people have really embraced annotations when they were added to Java. But the use of reflection and so forth on those same classes meant that higher memory consumption was the end result because of the way existing frameworks are constructed. And we started thinking, why can't we be more efficient? Java's problems are generally always exaggerated. Java has, in my time working in Java space, it has been dead several times over. But Ruby and Rails was going to kill it, and then Node, and then something else, and then something else. And the thing is that Java can be fast. So Android and Micronaut are examples of that. The issue really is that most traditional tools for server-side applications are based around three fundamental principles, which is the use of runtime reflection to analyze the classes that form part of your application, the use of runtime proxies, which again require reflection, and also potentially the use of runtime bytecode generation, using either something like ByteBuddy or cglib. Now, some of these tools like ByteBuddy and cglib can actually be used at build time, but typically people don't do that. In most common cases, the bytecode generation part ends up happening at runtime, which only ends up consuming even more memory. So you may be wondering, I've been hammering on about reflection and why it's a problem for a large application. And the good thing about Java today is it's all open JDK. So this particular reference relates to JDK 8, but the cost itself hasn't particularly changed a great deal. And you can have a look why reflection is expensive in terms of memory just by looking at the source code for the java.lang class. And the reason it's relatively expensive is because as soon as you access any reflected data, whether it be a method, whether it be a field, whether it be a constructor, the entire reflective data for that entire class is initialized and stored in soft references. So this is actually a battle we've fought many times in Groovy because it uses reflection extensively. In that all these fields and things are initialized. So if there was an API, this wouldn't be so much of a problem if we had an API in Java where we could say, I only need reflective data information for this method and that field and forget about the rest. But the issue is that everything is initialized, and these objects won't actually be garbage collected until your application is low on memory. So they're stored using what's called soft references. And the actual fields and java.lang.reflect.field and java.lang.reflect.method objects are not GC'd until your application is running low on memory. So an important lesson we learned is that, if we can avoid reflection at the framework level, that that will result in overall memory consumption and startup improvements. Using reflection is relatively slow. The only problem we found is that many existing specifications, including those within what was Java EE, now is Jakarta EE, mandate reflection. And most kind of modern server-side frameworks are kind of built on this model of using reflection. So it was really hard to avoid it without reviewing how we actually build applications. We look to the Android world, because if you look at Android, this is not like what I'm talking about here is not a new problem. It's not a problem that hasn't been solved, in that it already has within the Android community. Ahead of time compilation is used extensively in Android, and you have things like Google Dagger, which is a dependency injection framework, dependency injection toolkit, which I believe is the successor to Google Juice. And it uses annotation processes to eliminate reflection in your dependency injection code, thus improving your memory, startup time, and so forth for Android applications, which have the same more or less characteristics that you want in terms of a serverless function or a microservice that requires only using a small amount of memory. You have many Android phones out there that have a limited amount of memory, and applications need to start up fast. So we took a lot of inspiration looking at how things work in Android in the design and the creation of Micronaut. So for those of you who are not aware of what Micronaut is, Micronaut is a microservices and serverless focused framework, I guess, hence the branding, Micronaut. But it's also a complete application framework for any type of application. So it's not just limited to microservices. We have teams internally using it to build JavaFX applications, and Swing. So it's pretty much anything that has a static void main. It features, and we try to build something that reintroduces many of the productivity features of things like Spring and that people are used to. So things like dependency injection, things like aspect-oriented programming, things like configuration management, bean introspection, and so on. But without the end result of what you build being something that's going to consume a lot of memory. So, like I said, with Micronaut, you can build a variety of things. It has a large already ecosystem where you can build microservices, you can build serverless applications, the topic of discussion here. You can build message-driven applications that don't have a UI or an HTTP endpoint that just listen to streams of Kafka or RabbitMQ messages. Popular usage as well right now is to build CLI applications or command line applications with Micronaut. That just run on the command line and process data. We have support for Android, so you can plug Micronaut into your Android ecosystem, and basically that has benefits in terms of being able to allow you to share code between the server and the client. And pretty much anything that has a static void main can be used with Micronaut. So we like to see, what is Micronaut really? We like to see Micronaut as think of it as an application framework for the future, which changes the set of base primitives or building blocks that you use. Prior to building Micronaut, I was a Spring developer for 10 years, and I always thought of Spring as like the base building blocks of how you build an application. And with a set of kind of primitives that you use, beans and AOP, and this is how I construct my application. And Micronaut provides an additional set of primitives, these building blocks to build applications, but that eliminates the problematic areas that we have learned from experience are problematic. Things like the extensive use of reflection, so Micronaut is reflection-free. Things like eliminating the use of runtime proxies, and things like cglib and bytebuddy use at runtime. eliminating all dynamic class loading. So all static class loading is statically loaded. There's no URL class loader hierarchies or weird class loading issues that you can encounter. Using and providing a set of APIs, that, what we call ahead-of-time compilation APIs, that allow you to plug into the compiler in a language-neutral way. So whether you use Groovy, whether you use Java, whether you use Kotlin, in such that you can do things, more work at compile time. And yes, it does also let you build microservices. So a little bit of a history. We started development in Micronaut over 2 years ago. We open sourced Micronaut in May 2018, and the framework has really been creating waves ever since. Really had a massive impact and has grown massively in that time. And we've inspired. It's inspired industry-wide improvements to existing frameworks, and inspired also new frameworks to be built. Not naming any names here, but I should imagine you know who they are. There's the current status of Micronaut is that 1.2.6 is the GA release. It's built by the people that built Grails. So I like to think Micronaut is like taking all the lessons we learned over 10 years in framework design and hitting the reset button, starting again and thinking about how we're going to design a framework for the next 10 years. We've already reached 3,000 GitHub stars. It's used in production already in a number of companies, delivering real savings in cloud spend. We've had customers come to us already that said, we've halved our Google Cloud billing, switching to Micronaut from previous generation frameworks just by savings on memory. So these are some of the companies out there that are already using Micronaut, already embracing Micronaut. You probably have seen some of these names somewhere. Samsung, Target is a big US retailer. Minecraft, probably the biggest game in the world, I imagine, using Micronaut. So a whole bunch of other companies in addition to these. These are the ones I could manage to get permission to show their logos. The uptake has been stellar. And in addition to Micronaut, there's another project out there which is called GraalVM, which has emerged more or less at the same time as Micronaut, and it's essentially a whole suite of different projects under an umbrella called GraalVM, which is a new universal virtual machine from Oracle Labs. So it has a whole bunch of things. It has, for example, a replacement JIT for the normal Java virtual machine. It has things like the Truffle language framework, which allows implementations of languages on top of Graal, such as Ruby, such as Python. It has really nice interop between those languages in terms of zero overhead communication between different languages that run in GraalVM. And a kind of early adopter tool that's part of the GraalVM suite is a tool called Substrate, which is a native image, as it's being known. And what it does is it uses ahead-of-time compilation to convert Java bytecode into native machine code using AOT. And when we built Micronaut, we had no idea of the existence of GraalVM. Micronaut predates when GraalVM was open source quite a bit. And when we shortly after we open sourced Micronaut, it was announced, and somebody got in touch with me and said, "Hey, have you seen this?" And I looked at this and I said, "Wow, this looks really interesting." And it turns out that they're kind of Micronaut and GraalVM are kind of like a natural fit in a lot of ways. Because although GraalVM does allow reflection and has good support for reflection, in fact, it does have to be declared up front in the native image tool. So whenever a reflection is used, or whenever a dynamic proxy is used, or whenever dynamic class loading is used, you have to declare it to the GraalVM native image tool ahead of time. And I looked at this list of things and said, and I realized that, Micronaut doesn't do reflection, doesn't do runtime proxies, it doesn't do dynamic class loading. And so it turned out that putting it through GraalVM was just easy. It just worked. It was almost like they were designed to work together. So it's another very interesting project. Like I said, the native image tool is at early adopter phase as part of the GraalVM suite, but it's already supported by Oracle, I believe, and it's come a long way, and it allows you to convert Micronaut applications to native images, which has real benefits in terms of serverless, because you can, for example, a Micronaut app that's running within GraalVM can start up in like 15 milliseconds, more or less, plus minus. And when you get down to that level of milliseconds, what does 1 millisecond either way really make? And memory consumption is really low, so in comparison to the Java virtual machine. Now, it has some downsides: slower compilation time, kind of varied compatibility with the Java ecosystem at whole. So some things work, some things don't. Hence why I believe it's still early adopter phase. But it's immensely promising technology, and keep an eye on this pair being used more and more together. So in terms of Micronaut for serverless, we have fast startup time, the no memory footprint make Micronaut a good match together, and we have native integration with AWS Lambda serverless container, which you can find at that link up there. So Micronaut AWS is part of the Micronaut projects. And we also have native integration with Google Cloud Run and GCP in general, Google Cloud, you can find at that link. And we have, and also Micronaut works out of the box on things like the latest release of Google App Engine for Java 11, which is great as well. The original serverless platform, I guess you could say. And so Micronaut has a lot of serverless integration already. And in terms of how Micronaut solves those problems I talked about before, those limited annotation API, it solves them in a way by using an intelligent compiler plugin. So for the annotation problem, we pre-compute all the annotation metadata that the framework is going to need to make your application work at runtime. So all the annotations in your classes, and what annotations are annotated with what. For type erasure, we pre-compute the generic type arguments because they're already there in the source code, so that we don't have to do extra resolution. We eliminate reflection completely. We have no data caches in the framework itself, and we eliminate reflection data caches from third-party libraries we integrate with where we can. For example, we have a Jackson module, a module for Jackson and JSON that makes Jackson's marshalling and unmarshalling of objects reflection-free. We don't do any class path scanning, and we have no dynamic class loaders. So I'm going to start with doing some demos then of what Micronaut's capable of, and most of the rest of the presentation is going to be demos. So I'm going to start with one of the initial solutions that we came up with, which was bean introspection. So in a typical Java application, you may have like an entity like a pet or something like that, which has an age, and you're going to have getters and setters and stuff like that. And historically, what most frameworks have used what most frameworks have used to figure out the properties of a particular entity, for example, is what's called the Java introspector. So there is an introspector class in Java, which is java.bean introspector, and you can do get bean info, and you can get hold of pet, and you can get the bean info, and then you can do bean info.get property descriptors, and you can iterate over that. And this class, apart from being put into a different module, I think in Java 9 or something like that, uses reflection under the covers, and in fact, if you look at the implementation of how it works, it actually introduces yet another reflective data cache. So since this was such a fundamental primitive of the way things work in terms of frameworks, I'm going to go into presentation mode. We had to find a solution that replaced this out of the gate. So with Micronaut, what you can do instead is you can come in here and you can say introspected on the class and add the introspected annotation. And in my test, what you can do is then get bean introspection.get introspection pet.class, and we can get a reference to the bean introspection, and we can use the introspection to instantiate the pet, and then we can do things like we have an additional wrapper class which is quite handy called bean wrapper, which you can then get a wrapper around it. You don't have to use this, but it's quite convenient because then you can do things like set property name Fred and set property age 10. And then we can, system out value pet.getName or something like that. And so this is an example of, introducing a replacement that's a new framework primitive, which introduces a different way to do something that frameworks typically do, which is introspect your classes. So you can see I'm putting name, which upset. So with a bean introspection, you can retrieve an introspection for a particular class. You can then use it to instantiate that. And what Micronaut does is, like I said, it's an intelligent compiler. And you'll see that in the out directory of my classes, we can see that it generates an additional class, or classes, in fact, for that class that allows it to perform the introspections it needs to do reflection-free. And they sit alongside your existing code in those synthetic classes, so they don't appear in code completion in most IDEs and so forth. And it allows you to perform frameworky things like instantiate a class. Now, remember I mentioned annotation metadata. One of the reasons why annotation metadata, and we take it so seriously in Micronaut, is that it's typical in Java where you have things like validation rules like @notBlank here, and maybe on the method as well we have another validation rule that says min 5 or something like that. And you can see now immediately we have an annotation metadata problem here because for one, the not blank annotation is declared on a private field. The @size annotation is declared on the getter. So somehow we have to merge those two into a single view. Single view, if you see what I'm saying, because most specifications, for example, bean validation, allow either the annotation on either the field or the getter. And also, if we actually want to do that at runtime, we actually have to reflectively go in and retrieve the field, the private field, and essentially, break encapsulation potentially and do horrible things, which is not nice. And in Micronaut, that's not the case. So I can come into my pet test, for example, and from my bean introspection. From my bean introspection, I can, get rid of that. Introspection, I can say get required property. So I know there's a name property. You can also iterate over the different property names if you want. And that'll return me a bean property. And then I can do things like property.get annotation names by stereotype constraint. So I'm going to do a query on all the annotations that are also annotated with strength. Oops, I get annotation names. There we go. So that's the names, and we can iterate over those, and we can output that. And you can see that if we look at the not blank annotation, which is part of JavaX.validate, and the size, both of them are annotated with @constraint. This is what we consider a meta annotation. So not blank is annotated with @constraint. So, Micronaut provides this API where you can query for annotations by stereotype, or what we call a meta annotation, and iterate over them. So if I run this, you'll see that we're able to get all of the different annotations, which is size and blank. And it's dealt with the fact that one is declared on the field and one is returned on the getter, and essentially dealt with all that complexity but at compilation time. So everything is already set, everything is already read. Your framework that you're using doesn't have to go in and analyze your classes, which is really cool. So that is bean introspections. So introspected is an AOT reflection-free replacement for the bean introspector. You can get set, and it includes all the properties, and you can get all the annotation metadata, introspected, and so forth. And it includes knowledge of meta annotations. Another awesome thing about Micronaut is we allow the ability to map at compilation time the value of one annotation to the value of another annotation. So why is this useful? I'll tell you why it's useful. You know how many nullable annotations there are out there in Java? There's like 4 or 5 of them. There's java.x.annotation.nullable. There's org.jetbrains.annotation.nullable, which is from Kotlin. There's the one from Findbugs. There's the one from Spring Framework. There's nullable annotations everywhere. And if you're building a framework, you have to check, is this annotation present? Is that annotation present? Is this annotation present? And that's not the case with Micronaut. With Micronaut, because we process all of this annotation metadata compilation time, we can map all of the nullable annotations that exist out there in the ecosystem, or if you have your own version, and we map it to one, and internally in the framework, we treat them all the same. So that results in a much thinner runtime. The impacts have a ripple effect of creating a much smaller, leaner runtime with Micronaut. Same thing with generic type arguments. So you can, if I had a list of string, I could reach into my introspection and get hold of a reference to the property and get the first type argument for a particular property. And it's all ahead of time computed. And there's no crazy reflection logic to retrieve the type argument. Now, if you think resolving I'm making light of this, and you think resolving generic types is simple, I encourage you to take a look at this particular class, which exists in the Spring Framework. And this is the class that essentially resolves generic type information for Spring. It's called resolvable type. And you can see that, it keep going. So this is the plumbing code a normal framework like Spring needs to resolve generic type information. Yeah. That issue just goes away at Micronaut and creating a much thinner, much leaner, much smaller runtime. So that's 1,600 and something lines of code just to resolve missing generic type information. In terms of dependency injection, Micronaut again is Micronaut is really simple. So you can, for example, create a pet service here that is a singleton, and we can return a list of pet. That's going to be my list of pets, like so, and we can return an arrays as list, and we can have a new pet, Fred 10. Maybe we create that constructor, name, age, this dot name, this dot age, like that, and we can create another one, maybe Bob, maybe he's 8. Stick that there. There we go. There's a simple service. We can create a controller. And stick it in there. We can, inject my pet service. In Micronaut, we definitely favor constructor injection and immutability. So we inject it in there. We create an endpoint. So this controller is going to be mapping to /pets, for example. And this is going to be to the index section. So let's do list of pet. I have an index. And we do pet service.list pets. That's dependency injecting the pet service in there. How would I test this? So what I can do is easily create a pet client. Let's create a pet client. That is an interface. And so this is my client. And it's going to be a client that maps the pets URI. And we're going to get hold of a list of pet, like that. Using initially a blocking operation, like so. Then we can come into my test and delete all of this and clean up the imports and inject the pet client, like so, and write a test that exercises my endpoint. And we can say pet client, list pets, and get all the pets. And we can say assert equals pets.size. That's going to be 2, hopefully. And if the demo gods are with me and everything goes according to plan, then we should be able to run that test. And the test will fail miserably. Sorry? No, I think I missed the get annotation on there. So there we go. Okay, and you can see that this is a full REST client-server application. There's nothing mocking going on here. If you want to enable logging for the requests, you can say micronaut.http client level equals trace and add a logger. And you can see the input and output of the JSON happening. It's all built on Netty, so you can see the trace logging going in. So there's server, exchanges happening between client and server. And this demonstrated quite a few features of Micronaut, where we've got DI, we've got automatically implementing our pet client interface at compilation time. So this is a major difference between Micronaut and anything else. The implementation for this REST client is produced automatically for you at compilation time, rather than using runtime proxies, rather than using cglib, which results in better performance. And this is a blocking operation, obviously, but you can easily say, I want to return a flowable in RxJava of pet, and you can take that flowable then, and if I wanted to do a to-list and then blocking get to make the test pass again. Now that's not what you would use in production, obviously, but you would in this case you would take the flowable and you would subscribe to it. In this manner, to do reactive programming, but it's fully reactive, non-blocking, and what Micronaut's really achieved as well is in the past so many developers, Java developers in particular, ended up abandoning writing functional tests or writing fewer functional tests. I saw this all the time because their servers started so slowly, or writing more unit tests, less functional tests, and that's a shame because in a modern Java application, things should start fast, things should be quick, and you can see that I'm running my test here. It's exercising my full application, and it's executing ridiculously fast. So that is that is the power of pre-computing everything as we do in Micronaut. So Micronaut DI it fully supports the Java x.inject TCK. We support post-construct and pre-destroy. It's completely reflection-free and fast. We encourage constructor injection, as I showed. There's an application context object, much like Spring, where you can run it, shut it down, get beans. It's the kind of entry point into your application. You can retrieve, very much like Spring, an individual bean definition if you want to find out about the properties that are injected or to introspect it in some way. And it contains all the annotation metadata and so forth, which allows you to do frameworky things. We support type-safe configuration, so you can say add configuration properties on some configuration and have it bound to configuration. You can do, Micronaut will automatically detect the cloud environment that you're running in. So for example, if you run on GCP, it automatically activates a GCP environment. If you're running on Lambda, it automatically activates a Lambda environment. If you're running on Azure, it activates an Azure environment. And what that means is you can use things like @requires to say @requires env equals GCP and configure beans that only work for a particular environment. You can also @requires itself is very, very flexible, so you can say on a particular bean @requires this property to be set, or the presence of this bean, or the absence of another bean. So although Micronaut doesn't do any dynamic class loading and is completely static, you don't lose any of the benefits or the dynamicity of something like Spring. Micronaut AOP is also ridiculously cool, and I'm not even sure if I'm going to have time to demo this, but we're going to try. You can create, for example, a annotation called not null, and I'm just going to go to my client annotation and copy things because it's easier. And this is going to be an around device of type not null interceptor class. Import that, and it's going to be a not null interceptor. That's going to be a singleton that implements method interceptor like that. And you can just proceed with the invocation if you want. And apologies to those who attended my workshop. I probably covered some of these demos, but and you can get hold of the parameters, parameter values as an object array, and iterate over those, for example. And if a particular parameter value equals null, we can throw an exception, no illegal argument exception. Argument cannot be null at position, for example, I, something like that. Then you can go into a service, and say I had like a save pet method here, with the name, something like that. And you can add not null on that definition. And if I try to, in my test, if I try to inject that pet service, like so, and test not null, and I try to invoke save pet with a null value, you'll see that the interceptor gets invoked, and I get argument cannot be null at that position. So I've written a AOP interceptor without having to configure any proxy factory beans or do cglib or do crazy things with aspect-j or do anything like that. It just works, and it stays fast by doing pre-computation and pre-compiling. It also has an impact on your stack traces. So for example, if I put a breakpoint here, you'll see, and I can never figure out how to put a breakpoint in presentation mode. Where is my there we go. So if I put a breakpoint there and run the test again, you'll see that the actual distance, stack trace distance between when my save pet method is invoked and the interceptor, I don't know if you can see it down there in that corner, but you got 3 stack frames. And that has such a huge impact on performance, on debuggability, on how your application, how easy it is to debug your application. By eliminating those reflective stack frames, it's a big deal. By making stack traces smaller, applications are easier to debug and more efficient. So I'm going to rattle through a lot of this because we support different types of AOP, from around advice to introduction advice to adaptive advice. Around advice allows decorating behavior. So like the retriable annotation in Micronaut is an example of that, and that's how it's declared. You just say @around and point to a particular class, and it all happens at compilation time. As a kind of final demo, and it's damn lucky that I pre-computed this GraalVM application ahead of time before the conference talk, because otherwise we'd be waiting here, and with only like a few minutes left to go. But basically, I've got an application here that is a full, a more complete Micronaut application. It's got controllers, it's got 2 controllers, it's got repositories that are using JDBC, and a new project called Micronaut Data, which allows you to define things like dynamic finders, much like Gorm does in Grails. And the difference with Micronaut Data is it pre-computes the queries at compile time. So all the pre-computation is happening in the compiler, so nothing has to happen at runtime. And this application is a full, CRUD application, pretty complex app with like entities and domains and so forth. It's available in the Micronaut Data repository if you want to have a look at it. And you can see that when I compute this application into a GraalVM native image, even though it's creating tables at runtime and it's doing a bunch of inserts, which will slow things down a little bit, and it's still starting up in 35 milliseconds when you compute the application into a GraalVM native image, which is pretty impressive when you think about it from a serverless model, where you have to make sure that your response time, your cold starts are fast. So that makes it a compelling option for serverless Micronaut with GraalVM. Some of the startup time stats and so forth. Now, startup time isn't everything. Micronaut, optimizes memory, optimizes startup, but it also is trying to create a productive environment. So, but these are the kind of numbers that you're looking at. We've seen some improvements in JDK 13 as well with startup time, and with class data sharing as well enabled in JDK 13, which is awesome. You can really get regular Java's startup time down pretty far. And then with GraalVM, then you're looking at like 15 millisecond startup time, which is just like crazy and awesome, in terms of its potential. So I'll leave you with this message, and then we can have time for some questions. And I have a bunch of Micronaut stickers as well to give away if people want to for their laptops and so on. But I believe, and I think the trend is very much clear at this time. If you look at things like what Micronaut is doing, if you look at how newer projects like Quarkus have the approaches they've taken, and if you look at things like GraalVM and native image, that the future of Java is more intelligent compilers, and smaller, leaner runtimes. And that's really what we've been trying to achieve with Micronaut by creating a more powerful compiler that allows the runtime of Micronaut to stay small and not become really bloated in comparison to traditional frameworks. And you see that has ripple effects. Like, for example, a Micronaut application is only a normal one is only like an 11 megabyte jar file if you do an uber jar. And all of those has ripple effects in terms of GraalVM native as well, because the bigger your jar file, the bigger your native image. We need Java developers, and the Java ecosystem in general needs to be more efficient, get better in the face of competition from languages like Go, like Node, and I think this is the pathway forward: more intelligent compilers, smaller, leaner runtimes like Micronaut. So in summary, my belief is that Micronaut provides an awesome set of framework primitives, so that the end result of what you build, that beyond Hello World, doesn't involve long startup times and higher memory consumption. It does that by sacrificing compilation speed. There's no doubt about that. Compilation speed is slower, but not significantly so. And to gain so much more. And we're trying to solve problems that are, in general, with existing traditional toolkits like Spring and Jakarta and Java in general, and opens the door for GraalVM native. So thank you very much. I have time for questions. Probably have a minute. Does anybody have any questions? Yes, back there.
What about security? Authentication, authorization?
So we have, there's a project, Micronaut project / Micronaut security. Check it out. We support full JWT-based authentication. So that, and it integrates with Micronaut. Great, it already integrates nicely with OpenID Connect providers like Keycloak and Amazon Cognito and Okta, all those things. So check it out. Micronaut project / Micronaut security. Yeah.
So can we forget about Spring?
Can you forget about Spring? Absolutely. So Spring is great, and frankly, it's a technical marvel that they've managed to achieve what they have using reflection and runtime proxies, and it's an impressive piece of technology. But the outcome of using reflection is always going to be higher memory consumption, and I don't see how they can address that. They've improved things in terms of startup time, but the memory consumption issues remains. But not every application out there has those kind of constraints, or maybe it's okay occupying hundreds of megabytes of memory. I don't know. It depends on your requirements. Yeah.
Is there support for bulk reloading, redefining classes?
So we don't have support for redefining classes at runtime. What we do have support for is using Gradle's continuous build. In fact, we have support for fast restart. Because Micronaut starts so fast, if we have an option where you make a change and it restarts immediately. Now, I personally tend to use that feature very much. It's there and it works. My workflow tends to be creating tests, running tests, creating tests, running tests, creating tests. And in that, if you have that workflow, then you don't need to have a server that's self-restarting. But we do have that feature. There's a documentation section on that. Yes. I think I'm out of time. So like I said, I have a whole bunch of these awesome Micronaut stickers that you can come and get. If you have any other questions, I'll be in the hall. Give them. I have more than you can give them away to your friends. Take several. So if you want to come. Please do come get them, and thanks very much for attending my talk.